So good morning, everyone. Really happy to be part of this event. Thanks, Rohit, for inviting me once again. So today I'll be talking about how location-based artificial intelligence can be used across the EV ecosystem. And when I say EV ecosystem, I mean the battery makers, the vehicle OEMs, the EV fleet management companies, and the other organizations who are using EVs, and of course the EV drivers and consumers as well. So before I get into the depth of the analytics, I thought I'll give a quick overview of what the EV scenario in India is. So like Pushan also mentioned, the industry is still dominated by two-wheelers. So about 80-82% of vehicles which have been sold so far, they are two-wheelers and then followed by three-wheelers. And four-wheelers is still a small chunk of or small pie of the overall footprint of vehicles in the country. And we've been knowing about these challenges with respect to EV. There is, high capital cost because, batteries, they turn out to be expensive. The vehicle servicing is, from that perspective, the infra is not set yet. So those processes are to be implemented. Consumers still perceive this as a vehicle of the future, especially the consumers who are interested in vehicles for private use. They still think that it's going to happen in future and may not be the vehicle of today. And raw material for batteries has been a challenge and continues to stay as a challenge. In terms of technical aspects, battery efficiency, because that clearly defines the range, the total distance that one can travel till the battery goes empty. So driving range has been an issue, a cause of concern for the customers to adopt this technology. Charging time, so we have multiple solutions for charging, but still charging time stays as a concern. It's not as easy to get your vehicle charged as you can get your vehicle fueled up with a petrol or a diesel. And from infrastructure standpoint, charging infrastructure it is yet to be available properly. A lot of work, a lot of initiatives by government as well, but yeah, we've not reached there yet. And battery recycling from the perspective of environment, that has also been a cause of concern. So yes, in the middle of all these scenarios, we still, as an industry, as government, as globally, there has been we all want EV to happen and EV to happen as quickly as possible. So given these are given that you want the environment to be greener and you want all the drives to be greener and safer in future. So what do we do as at least I'll say on MapmyIndia's behalf what we are doing to overcome some of these challenges. So the point I'm trying to make here is that there is a lot of data which is available because majority of the EV vehicles are connected today. There's some kind of connectivity which is available, which leads to collection and capturing of huge amount of data. I'll talk about some of those data points that we all have access to. So, for example, for from the vehicle and battery perspective, for every drive, one can clearly monitor what is the state of charge at the beginning of the drive and at the end of the drive. So what percentage was it at the beginning? And whatever that percentage, let's say it was 80%, what was the claimed distance before start and end of the drive? Whatever we claimed, whatever the vehicle or vehicle battery BMS was claiming, is that the distance which the vehicle has been able to deliver as well in terms of range. Percentage energy used per drive. That's another input that we do get from the vehicle if the vehicle is connected. Percentage region in the drive. So this is quite important. So better the region, higher is the range or higher is the distance to empty. And region, if the user is educated on how to use the vehicle to improve this region, the range of the vehicle really improves. People who have driven electric vehicle, they would totally relate to this. Total distance traveled, the speed, the RPM of the motor, what is the ambient temperature at the start of the journey, end of the journey, during the journey. For every drive, what is the drive mode which was used, a unit electricity rate that been aware of, traffic data, the HVAC air ventilation inputs. So a lot of these data points are available with us for each of the drives. In addition to that, when these data sets which are coming from telematics or vehicle BMS, when they are married with location data, when I say location data, it's about terrain. Is it city? Is it highway? Is it off-road? Is it up? Were you driving uphill? Were you driving downhill? That information adds a lot of further value. Even from the perspective of road, what kind of road attributes exist for the roads that you have been driving on? Is it a highway? Is it, what kind of speed limits are there? Are there too many traffic lights? Is the road condition very poor, in the sense it's not smooth enough? So these data points also can add a lot of value to the analytics or to the use cases that I'll be talking about in future in my coming slides. Traffic congestion related information, again the temperature, because temperature does impact the charge retention in the vehicle, and millions of places and destinations for both personal and commercial drives. So a lot of this data is available, and you can always derive the driving behavior and calculated driving scores for each drive and for each driver. So given that all this information is available, I'll just first talk about the road attributes which one can have access to. So width of the road, the slope, the curvature, so that basically helps you with the terrain, where the potholes are, where the speed breakers are, the real-time traffic flow, the form of way. Is it part of a flyover? Is the road that you're driving on is a part of bridge, tunnel? Is it a one-way, two-way? So a lot of these data points are available. Now, how it helps, how we can put this data to use. So the first use case that I'm talking about here is the self-learning model. It's an AI-based model for a reliable and more accurate dynamic range calculation, where you take inputs, the list of attributes that I just talked about from the vehicle, about the driving behavior, about the battery level and type, the road topography, and weather. We use all these data points, and we let the vehicle self-learn about the range calculation, and so that user gets more confidence on the range which is being shown on his vehicle cluster, that can really be improvised and can be made more reliable. Second is knowing the location of EV charge stations, where the EV charge stations are. That's another reason for users to feel comfortable about about buying and owning an electric vehicle, especially if you have information about the compatible charge station with the right plug types. Now, availability of charge stations, knowing the accurate dynamic range for your trip can help in a further advanced use case, which is battery efficient navigation, wherein when you enter your destination into the system, it helps you figure out whether your destination falls within the vehicle range. If it doesn't fall, then it can guide you to go to a charge station en route, get your vehicle charged up, and then you proceed towards your destination. So those kind of solutions really help in solving the range anxiety for the consumers. Driving behavior definitely can be calculated. The other aspect, the other use case that I wanted to focus on was around the EV charge station site selection. Today, this has been one of the major concern, because infrastructure, charge station infrastructure provider really don't know where do I put up charge stations first to get the maximum footfall also. So typically what the process that they use is they send people out in the field. They try to get access to data of petrol pumps. Maybe they seem to be one of the candidates, one of the important candidates to put a charge station. And all this leads to high operational costs. So this can clearly be avoided by using the available data sets on traffic flow, on road topography, and nearby amenities, nearby power stations, and so on. And there are algorithms that can help you do a range, do basically a site selection, a catchment analysis based using the AI-based algorithms. This is an important one. The analytics can also help create a personalized consumer guide for efficient driving. So if I am driving a vehicle, I may have different driving patterns than somebody else. If the vehicle is reading the way I'm driving, that information can be used to guide me how I can make my drives better, how it can help in showing areas where one could have region better, encourage region by showing different drives. So from point A to point B, the system can tell me that why don't you use this drive, because this will have better region and better range. It will help create better range for your vehicle, for your drive. Promoting eco-range driving by using driver analysis. So we are able to analyze, get outcomes like what is the SOC that got consumed in a drive, the energy that got used, what was the cost of a drive, what turned out to be the cost of a drive in the past, what was your region score. And basis that we guide, we just don't give a score, but we help user give a more useful information to make his drives better. So predicted versus actual distance, terrain versus range analysis. So a lot of this information can be made available. And in an overall scenario, the user can get access to his region scores, whether he's a charging pro, because charging cycles also need to be looked at. The optimized, whether he's charging his battery, charging his vehicle in an optimized way, or after every 30% reduction in the SOC, he goes and he recharges it again, because there are limited number of battery cycles that can the charge cycles that a battery would support for its lifetime. So region scores, charging pro, eco pro, these kind of inputs can be made available to the users. From the OEM point of view, and also the battery maker's point of view, you get to understand what is the battery efficiency for each charge cycle, how the battery behaved, what was the difference between a claimed DTE and the actual DTE. Output per charging in the similar way can also be calculated, and a coaching to the driver can be given. So inform user of improper charge cycles, showing benefits, that how it can help if he had used a proper charge cycle system. So these were more from the consumer point of view, but from the OEM point of view, getting to know, basis the location information, one can get to know the usage split of your vehicles across urban and rural geographies. Even within cities, what kind of roads, what kind of areas, what kind of localities are these vehicles being driven, and for what purpose? So that kind of analytics can also help OEMs take the right decisions in terms of focusing their sales and their in the market. Customer behavior analysis. So here what we're saying is that one can analyze what are the most frequently visited places, what are the most common routes being used for the EVs, and then they can be further categorized by personal use and also the commercial use. What is the duration of stay, transit, travel time? You basically get a pattern of usage of your vehicle and also the movement of your users. And all this put together can help again in being more location aware and taking the right decision in terms of distribution of these vehicles. There we go around the traffic movement, the footfall across trade business. So retail and consumer insights can also be made available. That can also be a good, that can also help in decision making when you're expanding your network. So exactly what type of consumers are spending their time, which markets, how they are moving from one to point A to point B. All these different types of analysis can help build a better EV ecosystem is what I would say. So thank you. That's all from my end. I hope the information I shared was insightful for the audience. Thank you.